Good morning, everyone. Coming from an army background, I had the privilege of moving across 8 states, changing 14 institutions to complete my schooling life. It was a privilege because I got to travel across India, meet new people, eat excellent food, and imbibe the whole culture of this beautiful country. After this, like any clueless, normal middle-class boy, I ended up doing engineering. And like every middle-class engineer who finishes his studies, I, after that, ended up doing an MBA. Post my MBA, I had the fortune of working for a Fortune 500 medical devices company, which exposed me to the Indian healthcare system. While most of the times we were celebrating the numbers that we would achieve, it made me think we were actually celebrating more people getting sick. Healthcare in India is probably more about sick care. It's not preventive in nature. And that's where I thought about trying something new. And that's when, like a now cool middle-class engineer who does an MBA started thinking about doing a startup. So I moved to Bangalore. And that's when we started working on diabetes and some of its associated conditions. You see, diabetes is a condition. It leads to a lot of diseases, and some of which is what we work on. And we use technology as a medium to make about scalable solutions which could reach places which are genuinely overlooked because of the lack of infrastructure or manpower. I'm going to be talking about some of the things that we are doing. And this is one thing that I want everyone in the audience to think about. Can AI solve India's complex diabetic challenges? So I'm going to share about our approach for diabetic eye care and diabetic feet care challenges, starting with the case study of diabetic eye care and subsequently sharing a few things that we're doing in diabetic feet care, and then we'll come back to this question towards the end. 1/4 of the world's blind people are in India. Everyone in the audience, I want you to do one thing with me. Just close your eyes and listen to me for once. Just everyone in the audience, close your eyes for 5 seconds. Everyone, 5 seconds. See, blindness is silencing also. What you just experienced for 5 seconds is the reality of 1 crore individuals living in India. And why is this happening? 80% of this blindness is preventable or could have been prevented with early screening. And this makes us question, why are we not doing anything about it? And the answer to this question is actually very simple. We don't have the manpower. We have 1/5 the WHO recommended ophthalmologist to patient ratio. And not just that, 70% of the doctors that we have are based in urban areas, catering to close to 28% of the population. So in some of the places which are in rural areas, our doctor to patient ratio and access to healthcare is probably worse than some of the countries out there in South Africa. Take that as a thought. And between the reality of healthcare infrastructure, we get WhatsApp forwards like, will AI replace doctors? There are no doctors to replace in so many places. What will AI replace? I think so. AI will play the role of bridging the gap. And I'm going to share our experience of building a system reliable for screening patients for the rural hinterland. But first, let me tell you about artificial intelligence. How do you build an AI? Right? It's a buzzword sitting in a medical college. We think of a small baby, right? We have all got neurons inside us, neural networks with which we make patterns, areas in our memories. Think of AI just like that. How do you teach a baby or a child what is a dog? Do you start defining different characteristics of dogs? You don't do that. Do you start sort of talking about different things that a dog does? No. You just show a baby, that is a dog. That is a dog. That is a dog. A baby looks at other animals and it already sees, okay, a dog has certain features which differentiate it from a bird, from a fish, from a cat. Maybe how it looks, maybe the number of feet, maybe it has a tail, maybe it makes what kind of sound. So, in short, it is exposed to a number of images or instances where you showcase a particular example without defining too much about it. And that is how you explain it to a baby. And that is how their internal AI or neural network works. It is very, very simple to how a real AI works. You expose it to large data, and using that data, you train an algorithm to start understanding basic patterns. And that's how we have gone about training different kind of artificial intelligence algorithms. I'll take a small example. How did we go about building an algorithm which could understand what is diabetic retinopathy? It was again very simple. We had to collect thousands of images, both of two categories. Number one, you need to teach an AI what is diabetic retinopathy, where it is positive. And then you have to teach an AI where it is a healthy case, but it is not as simple as that. For example, if a patient has diabetic retinopathy, there may be a case there are comorbidities. That again goes into a data engineering. You have to curate data sets in such a way that you are training them for the real world. And similarly, a glaucoma patient from an AI perspective is healthy for diabetic retinopathy. So you have to get into complexities in terms of teaching it real world scenarios and making it work in the real world. The biggest challenge that any AI company in healthcare will face is data. How well you curate your data. Imagine getting 1 lakh images and then getting a team of super specialist doctors to start looking at every image, making a diagnosis. So what we had to do was, got together a team of 32 doctors, got a data set of 2.5 lakh images, and these images, each image was labeled by a minimum of 3 doctors. And then the ground truth, when 2 doctors agreed on something, was set as the ground truth of image. And that data set across different categories was used to train. There are very, very big companies worldwide which are trying to do similar things. And we all face a common problem. Doctors are busy people. And data labeling is the boring thing. It is the most boring job you can ever think of. Imagine opening a laptop without any context, any motivation, just assigning ground truths to an image. So how did we crack this problem? We had to do it. We did not have the money like the big gorillas of the world like Google, Verily Life Sciences, Microsoft. But we had ingenuity. We ended up creating a smartphone-based tool. So currently, they were using laptops, opening it only on weekend to label data. We created a game-based system in which doctors could open up their smartphone, look at the images, assign label, and we were able to clinically prove this through a study that our tool made doctors way faster, more productive and accurate in terms of labeling data. We again got thousands and thousands, by now it has crossed into lakhs, number of images labeled by super specialists. And the resultant AI, this was in 2021 starting, had very good amount of accuracy. It actually proved to be around 89 to 87% accurate across 3 data sets, out of which only 1 was internal, 2 were external. It could identify, it could look at an image and see if there was diabetic retinopathy or not. And this was done with only 16,000 images. Currently, our AI has been trained with 20x more images than what it was at this stage. But again, one problem that clinicians will face and a challenge that they will pose. Yes, it is an accurate system, but why is it making this call? You may have 90% accuracy, but can you explain me why this is 90%? Why did the AI take this call? If you cannot trust the AI, you will never use it. So that is the black box problem of a yes or no AI. And we thought we need to go a step beyond in terms of just coming to a yes or no AI. We need to have explainability. We thought we need the AI to truly learn what the eye is all about. And then we started doing some experiments. And I'll show you what all our AI has learned till now. And the performance, you'll see it on the live screen right now. We actually took the AI, started teaching it about the microvascular system, and by now, the AI in itself is able to differentiate the arteries and veins from a simple image. There is another very special I'd like to talk about. Access to data is very, very difficult in India. We used a new technique of AI to create synthetic image. What you see in front of you is an AI-generated image, which is not a real patient, but anyone who comes from the field of ophthalmology will see this as a real image of optic nerve head. And our AI has been able to generate it. It has learned the contours and the specifics of the optic nerve head. This is all very important for glaucoma. But then what else can we teach our AI? We started teaching the AI about microaneurysms. The appearance and disappearance of this lesion across 2 patient visits can give a very good idea to a doctor how the disease is progressing in terms of diabetic retinopathy. Similarly, we started teaching it more things. So you can see the slightest of hemorrhage, the AI has picked up and it has started learning. And this is where we start seeing it has started picking up soft exudates, hard exudates, and it's the smallest of things which, given the kind of complexities, given the time crunch, given the patient workloads, it is sometimes easy to miss out on. We hardly have 3,000 to 4,000 super specialist eye doctors in India. Imagine if such kind of system could be provided to a general ophthalmologist or in a remote place of Jammu to a regular doctor or a regular technician just with a machine. We could identify cases which need to be referred to a specialist years and years in advance with such a system. Again, we were also able to teach it more features like neovascularization. These are all features or lesions which are associated either with different stages of diabetic retinopathy or more diseases of retina. And imagine an AI is able to not just detect it but learn different features. And that is what we teach in medicine also. This is at an early stage. Now, what we are trying to do is, we are trying to teach our AI to do something phenomenal. This is an imaging from a machine called as retina machine, fundoscope machine. It is a 2D machine. It shows you a 2D image of the eye. For a lot of diseases like glaucoma or diabetic macular edema, sometimes you require a much more larger machine called as OCT machine, optical coherence tomography machine. This machine is bulky. There are close to 750 of these machines in India, and they cost somewhere around 20 lakhs to almost 60 lakhs. It produces a 3D output. We are using AI to start producing depth and thickness relating to glaucoma and diabetic macular edema, and use that as biomarker and give that output from a 2D imaging, something which human eye possibly cannot do, but AI is able to bridge this gap and give extra clinical information. This is the power of AI that can be brought about to existing system, and this can be sent to the remotest village just as a software update. And the best thing about all this, did I tell you that all the things that I told you about in terms of what an AI is able to do in terms of reading an image, it can do all those analysis in under 10 seconds. So imagine, and let's reimagine, public screening, healthcare, eye care, overall patient to doctor relationship. When you could spend more time explaining to the patient, when you can spend more time being more analytical, this will change how doctors start treating their patients in terms of being more data driven. And that's the whole goal. Our goal is to make doctors take decisions which are based on data and their communication with the patient and the history and their own education. That makes a more complete and comprehensive healthcare that we are here to bring about. So this was about the eye care. What else? AI, there is a new technology, right? But there are also new other technologies coming into being. And how will AI set in with other new technologies? There are technologies like Internet of Things, which is connecting any standalone device to internet, be able to digitize it, be able to transfer the imaging from a remote setting of one device to another main area where you want to do it. There are technologies like 3D printing. So I'm going to give you an example of how these technologies could come together and disrupt healthcare. I'm going to share something that we are doing in this field. We are using technologies like AI, IoT, and 3D printing for diabetic feet care, point in being custom orthotic development. Why does one need custom orthotics? Well, a lot of reasons have to do with simply sheerly your pain, which is arising out of because of some problem that is there in your feet, but also diseases like diabetic neuropathy and diabetic ulcers. Apart from that, diabetes induce more higher chances of arthritis and osteoarthritis. Sometimes doctors will prescribe you custom orthotics for this. It is a very cumbersome process. In a city like Mumbai, just a simple inserts into your feet will cost you around 8 to 10,000. It takes close to a week to build, and it's a very cumbersome process. How cumbersome? Let me tell you. The existing process has multiple steps, but let me talk about 3 major steps. You take the plantar pressure. You need a digital machine for that. It costs around 5 to 6 lakhs right now. We are working with a set of researchers at IIIT Hyderabad. We have brought about a machine which is costing less than 50,000 of what a 5 to 6 lakh international machine is doing. We are making this in India. It's an Indian innovation, and it is performing exactly same like what an international machine is doing. Second, you need to make a 3D model of the feet. Currently, there are 2 ways they are doing this. Putting the patient's feet in a plaster mold. That you can very well imagine. You have to clean the feet. You have the kind of mess you make. Or else, again, there are machines which cost 5 to 6 lakhs which are able to do it. We again use AI to simply take your smartphone, click a 15 seconds video of the feet, and we use artificial intelligence to create a 3D model which is more accurate than the 5 to 6 lakh machines out there. And this again disrupts the costings of setting up such a service. Finally, the orthotics development. A skilled technician has to sit, cut through multiple layers of materials, stick it. It takes 3 to 7 days for a trained technician to do this. We use 3D printing as a technique and flexible filament, where using material size, we are able to make the custom orthotics hard at same places, and using the exact same material, we are able to make it flexible and soft at certain areas. Imagine taking 15 to 20 lakhs to set up such a service. That is why the customers are charged 8 to 10,000. My dear friends, we are able to do this for under 50,000. Imagine the cost advantage we can pass it on to the patients out here in India. So this is how we have personalized the whole orthotics for Indian settings, while Yes, you can have inserts for sports shoes. We started doing the sandal-based inserts. And I actually went to a 5th generation cobbler. This person's family has been doing this since British era. He's a 5th generation person. I took the orthotics, gave it to him. He inserted this particular technology into the sandal. And there you see the best example of technology coming together. Imagine artificial intelligence, 3D printing, high-end IoT, meeting a regular cobbler on the street and coming together to make a product like that. That is the new India which is coming together, and that is the kind of technologies that will usher in the new era in healthcare. Finally, I would like to conclude by saying necessity is the mother of all inventions. For me, it was all about my mother. That was the motivation of my inventions. My mother is a diabetic. She has had cataract surgeries. She's got problem in her feet. I have seen problems in my own house. I know the motivation of a patient when even one medicine increases, how it affects their psyche, how it affects their overall motivation. So that is the empathy with which I started building this solution. There are a lot of people like me. There are a lot of change makers and technologists like me. There are technologies which will be spearheaded by engineers. There are technologies which will be spearheaded by scientists. But I would like to remind everyone in this audience, there are technologies like medical AI which need 2 parents. One will be the data scientist, AI scientist, and technologist, but the second parent will be doctors. Doctors will be the one who will teach an AI what is right, what is wrong. Doctors will teach an AI the right ethical boundaries. Doctors will teach the AI when to take what call. So to every one of my friends out here, embrace it, nurture it. You are going to be part of the revolution. You are part of this whole journey. Thank you so much, everyone.